So, hi guys, my name is Sharan, and today I will be presenting a seminar on drop weight testing, focusing on two important tests. One is dynamic tear test, which is also called as DT test, and other is Robertson crack arrest test, which is commonly known as CAT. So, these tests are used to understand how materials, especially steels, behave under sudden impact and how they resist brittle fracture. Before getting into the test, let's understand why we need them. At low temperature and high loading rates, many steels become brittle. Brittle fracture is extremely dangerous because it occurs suddenly without warning. Engineers need reliable methods to predict when and how fracture will occur. This is where drop weight tests become important. It studies the ductile to brittle transition point. It is similar to impact testing, which we carried out in a CHARP and ISO test. Uh, it helps to prevent sudden brittle fracture. So, ductile fracture happens slowly, following necking first, and then the crack propagates slowly, and then the fracture occurs. But while in a brittle fracture, this case uh, everything happen in a fraction of seconds, and the crack happens instantly and failure occurs. So this is not preferable in practical materials. So what is a drop weight test? The drop weight test is a large scale impact test used to determine nil ductility transition temperature. um, a heavy weight is dropped on the specimen. The specimen contains a small starter crack. If the crack propagates rapidly, that means the material is brittle at that temperature. If not, it still has a ductility. This gives a safe temperature limit below which the steel must not be used. So, what's the purpose of a drop weight test? It checks the ductility at low temperatures to prevent catastrophic failures, which is crucial in pipelines, bridges, and pressure vessels, etc. So, what is dynamic tear test? So, the dynamic tear test is similar to a giant Sharpie testing machine uh, to measure the energy absorbed by material when torn dynamically and to study brittle fracture behavior. It studies the brittle fracture behavior on impact. So, here is the specimen of a dynamic tear test. The dimensions of specimen ranges from 5 by 8 to 1 inch thick. While these are the standard dimensions, the dimensions can go up to 12 inch thickness. Uh, it contains an embrittled electron beam weld, which is the starter crack or notch, which initiates the crack. Uh, it is similar to Charpy test, which applies the impact energy in opposite to the crack. So, how does the DT test works? The pendulum strikes the specimen in similar way to Charpy test. The crack propagates. The energy absorbed is recorded. Uh, what's the difference between Charpy and DT test? The same pendulum type machines is used in DT test, but here it is much heavier. The Charpy testing machine handles up to 240 foot-pound limits, while DT test machine can handle a capacity of 10,000 foot-pound capacity. The pendulum strikes the notch specimen. The crack propagates across the width. Energy absorbed is the main value that we record in this test, which gives the ductile or brittle behavior. So why DT test is used? It measures the ductile to brittle behavior, useful for large steel plates, more realistic than CHARP, which uses standard small specimens, while here the higher thickness of materials can be tested. Gives a quantitative measure of fracture toughness, stimulates conditions similar to large structures, pipelines, pressure vessels, etc. Useful in understanding transition from ductile to brittle behavior. So our next test is Robertson crack arrest test. This test is used to determine the crack arrest temperature, the temperature at which the crack stops to propagate. Uh, the temperature at which a running crack stops because a material becomes ductile enough. This test helps engineers know how steel behave under rapidly propagating cracks. So here is the specimen normally used for Robertson crack arrest test. Here the impact energy is applied on the left side and heat is applied on the right side. A small static crack is present here. A wide plate specimen is used around 6 inches wide. This is a starter crack. Uniform tensile stress is applied perpendicular to the direction of impact. The one side of specimen is heated, which creates a temperature gradient. This means one side is cold and brittle. This side is cold and brittle, and this side is hot and ductile. So how the crack arrest test works? The crack starts from cold region. It starts from here where the notch is present and impact energy is applied in this direction. So when the notch observes the impact energy, the crack propagates slowly. It starts to move towards the hot region, and at some point the temperature becomes high enough that the steel becomes ductile. The crack slows and stops. This temperature is called as crack arrest temperature. So crack arrest temperature, the temperature at which running crack stops, used for deciding safe limits. CAT indicates that safe temperature range for steel structures. If the working temperature is below CAT, brittle fracture can occur, which is not desirable. If above CAT, material stops cracks naturally, as we seen in the before slide. This is crucially important for bridges, ships, pipelines, pressure vessels, etc., where temperature plays an important role. So, what's the difference between dynamic tear test and crack arrest test? In dynamic tear test, we measure the impact energy, while in Robertson crack arrest test, the temperature at which the crack arrest is noted. The type of loading is impact loading in dynamic tear test, while here in Robertson crack arrest test, the temperature gradient plus tensile stress is introduced. The result from dynamic tear test is toughness value, while in CAT it's temperature where the crack stops. So here we come to the conclusion. The dynamic tear test helps in determining the impact toughness of a material. The Robertson crack arrest test gives a more realistic picture of how a running crack stops in thick plates. Both tests are crucial for ensuring the safety of large steel structures, especially in cold environments. So when we come to the cold environments, uh, it is crucial to note the famous example for this type of fracture, which happened in Titanic shipwreck. So we all know about the Titanic shipwreck, right? Right. So it happened because of this ductile to brittle transition point. The Titanic disaster is a classic real-life example of brittle fracture. The steel used in the Titanic hull became very brittle in the freezing North Atlantic water. Because of this, the ship hit the iceberg. When the ship hit the iceberg, cracks spread very fast instead of observing impact energy. That's why the ship broke into half instead of forming a small crack. Uh, so this would have not been the case when it hit a normal stone or a rock in normal temperatures at sea waters. This happened because it hit an iceberg at very low temperature at freezing points. So the material of the ship became brittle. That's why the sudden failure occurred. Tests like drop weight test and dynamic tear test helps engineers understand this ductile to brittle behavior today. Robertson cracker test also shows how cracks can be stopped before they cause major failure. If such tests and knowledges existed back then, stronger and more crack resistant steel could have been used, possibly reducing the damage. So these tests are important because they help prevent disasters like Titanic by ensuring materials stay safe even in very cold conditions. So that's all, guys. Thanks for listening.